Salam and welcome everyone. So today we're going to be working on the question on the screen that says use Troughton's rule to predict the enthalpy of vaporization of cyclohexane from its normal boiling point 80.7 degrees Celsius. So of course we know that we're dealing with Troughton's rule, and Troughton's rule is a rule in physical chemistry that has the formula change in enthalpy of vaporization, or change in standard enthalpy of vaporization is equal to the boiling point temperature, times the change in entropy of vaporization. So, or change in standard entropy of vaporization. So, this is basically what we're dealing with. We're told the boiling point for this question is 80.7 degrees Celsius. So, TB is actually 80.7 degrees Celsius. The next thing you have to do, of course, anytime you're given temperature questions like this, is to go from degrees Celsius to Kelvin. So TB ends up being 80.7 degrees Celsius plus 273.15 kelvins. So I'm doing the calculation on the side. We know that to be TB, 80.7 plus 273.15 is going to give you 353.85 kelvins. So this is basically how it's done. So let me rewrite that because it's kind of smudged. So TB is 353.85 kelvins. So now you'll be wondering, okay, we're told to find the enthalpy of vaporization. So we're supposed to find this one right here, right? But we only have the boiling point temperature. We don't have this one right here. But as any chemistry student would know, whenever you're given a physical chemistry question, you should also have the information on, you should also be used to checking for values in the resource section of your textbook. So in the resource section of my physical chemistry textbook, I see that the value of the change in change in entropy of vaporization is actually 85.1 joule per mole Kelvin. So that is it. So now we have the boiling point temperature, and we have, of course, the change in entropy of vaporization. So we can just substitute in this equation. So having this equation, we have, or rewriting this equation, we have change in enthalpy of vaporization is going to equal, just rewriting the formula and then substituting. Is what I'm trying to do right here. So change in enthalpy of vaporization is equal to 353.85 kelvins times, so that's the temperature, times change in entropy of vaporization, which is 85.1 joule per mole Kelvin. So divide Kelvin, divide Kelvin. So we have the change in enthalpy of vaporization is equal to this information right here times this information right here. When we input that in that calculator, we get 30,112.635 joule per mole. Okay, so that's basically how it's done. Now, let's not forget that in enthalpy in enthalpy or change in enthalpy that we've been given thus far, a lot of our questions or answers or the values have been given to us in kilojoule per mole. As you can see in this question, is much greater than the change in enthalpy. So we can go from joules to kilojoule per mole. So all we have to do is just divide this information by 1,000, because when you go from joules to kilojoules, you divide by 1,000. So the change in enthalpy of vaporization can be rewritten as 30, 0.11264 joule per mole. So this is basically, kilojoule per mole. So this is basically the answer. But our work is not done. Because we're dealing with a question in chemistry, we have to look for the sig figs so that we can put in the proper answer in the proper sig figs. We see that we're given the normal boiling point to be 80.7 degrees Celsius. So that means our answer will have to be put in 3 sig figs, because 80.7 degrees Celsius is in 3 sig figs, as well as change in entropy of vaporization is also in 3 sig figs. So we can put our answer in 3 sig figs. So we end up having the change in enthalpy of vaporization for this particular question to be 30.1 kilojoule per mole. So this is answer to this question. If you have any questions, please put in the comment section. If you have any concerns, also put in the comment section. I am a tutor and mentor who helps students who are struggling in all their STEM related courses succeed, whether they're in middle school, high school, or college. So if you'd like to know more about my services, email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.